Welcome back again. So I just continuing with the next question. So remember, in every back titration, we're supposed to have a reaction and a titration. So you can pause the video and see if you can pick out the information for the reaction separate from the titration. So you can pause now and try. Alright. So it says a type of calcium supplement, and when you get the question, it can have some excess information that it's not needed for the calculation, right? So if the question is long, just read and pick out the necessary information. So the first sentence, one type of calcium supplement tablet consists mainly of calcium carbonate, but also contains several other substances. One such calcium tablet weighing, right, so our first information, right? Well, not the first, because we know they are talking about calcium supplements as the tablets that contains calcium carbonate. And it says one such calcium tablet, so we know the tablet weighs is 2.9072 grams. And we add that tablet to 50 ml of 1 moles per DMQ HCl. So if the tablet contains calcium carbonate and we add it with HCl, we know a reaction is going to take place between the calcium carbonate and the hydrochloric acid. So again, here the question gave you the reaction. It's the tablet reacting with the HCl. Specifically, the calcium carbonate in the tablet reacts with the HCl. And they tell you that the HCl was in excess. And as I said in part 1, we are interested in the tablet, so we need to ensure that all the calcium carbonate present reacts. So we need to add an excess amount of HCl, which was done. Now they said the excess here, the excess means what was left over, what did not react. So the unreacted acid was titrated. So here they are talking about the titration. So the excess acid was titrated, and they gave you the volume and the concentration of the base, which is sodium hydroxide. So it was titrated with this volume and that concentration of sodium hydroxide. And they want the percentage of calcium carbonate in the tablet. Alright, so go ahead, set up the reaction step and the titration. So for the reaction, we need so we know we have this sample of the tablet, alright? So we have the mass. So the calcium tablet it weighed 2.9072 grams, and we use HCl, alright? And whatever HCl is used there, that's the total. So we know we have the concentration and the volume, so we can use that to find the moles of HCl. Right? So we're going to find the total mole of HCl. And we know mole is concentration times volume. The concentration given was 1 moles per DMQ. And the volume was 50 ml, which is 0.05 DMQ. So DMQ cancels DMQ and left with mole. So in the reaction, we use a total of 0.05 moles of HCl. So if you are following the procedure from step 1, after you get the total mole of HCl, we are going to write the reaction. And remember, the reaction is between calcium carbonate, right, and HCl. Remember, it was the tablet that we add to the acid. So the state symbol is solid. Always put your state symbols for your equations. So calcium carbonate plus hydrochloric acid, you are going to get calcium chloride, carbon dioxide, and water. If you balance this equation, you should get a 2 in front of the HCl. And we are interested in what? The calcium carbonate and the HCl. So the mole ratio between calcium carbonate and HCl, 1 calcium carbonate to 2 HCl. Alright? So the mole ratio is 1 to 2. Alright? So remember, we stopped at the equation and the mole ratio for the reaction. So now let's go over to the titration. And for the titration, they gave us the volume and concentration for sodium hydroxide. So we know from part 1, we are going to find the mole of sodium hydroxide. So in the titration, we use sodium hydroxide. So the mole of sodium hydroxide is concentration times volume. And the concentration is 0.102 . Volume in dm cube, that would be 0.02 888 dm cube. For moles, you should get 2.95 times 10 to the minus 3. So that's the mole of sodium hydroxide. And we know that what we are trying to do in the titration is to get the amount of moles of HCl that was unreacted. So once you get the mole of sodium hydroxide, we need to write our equation. So sodium hydroxide reacts with HCl to give us sodium chloride and water. Now we know the mole ratio between sodium hydroxide and HCl is 1 to 1. Alright? So if the mole ratio is 1 to 1, then the mole of HCl, so the mole of unreacted HCl is equal to 2.95 times 10 to the minus 3 moles. Right? So the moles that reacted, the moles of HCl that reacted, it would be the total. So remember, it's total minus excess or unreacted. So it is 0.05 take away 2.95 times 10 to the minus 3, and for that you should get 0.0471. 0.0471 mole. So now we know the mole of HCl that was unreacted, not unreacted, we know the amount of moles that was reacted. So once we get that, we come back to the reaction. And the mole ratio is 1 mole of calcium carbonate to 2 moles of HCl. So the mole of calcium carbonate, is 1 over 2 times 0.0471. Or you could just divide by 2. Right? And you will get 0.0236. 0.0236 moles. So that's the mole. And we know that mass, because remember the question wanted the percentage of calcium carbonate in the tablet. So we need mass. And we know that mass is the mole times the molar mass. So it would be 0.0236 mole times 100 gram per mole. And we would end up with 2.36 grams. So now that we have the mass of calcium carbonate, we just need to find the percentage. So it's the mass of the compound over the mass of the sample times 100. So the percentage, it's the mass of the compound, which is 2.36, divided by the mass of this sample, which is 2.9072 times 100, and you should get 81%, 81.2. Right. So that's how you do it. Right, we're going to do a next question. So, yeah. Right, so this is the next question. You can pause, write it off, and try it. Alright, so in this one, it says that fertilizer contains ammonium sulfate and potassium sulfate. A sample of 1.455 gram of the fertilizer was warmed. That means a reaction is going to take place. We are mixing the fertilizer with sodium hydroxide. So that is the reaction. Alright? So a sample of the fertilizer was warmed with sodium hydroxide solution, giving off ammonia. That tells you the reaction took place. Alright? So that portion is the reaction. The remaining sodium hydroxide, or the unreacted sodium hydroxide that was not used, required that of HCl for neutralization. Once you see the neutralization, that tells you it is the titration. So again, as we have done in the previous two examples, divide the question into the reaction and the titration. And of course, we are going to calculate the percentage by mass of ammonium sulfate. So we are not interested in the potassium sulfate because it only asks for the percentage by mass of ammonium sulfate. So the reaction, we are interested in the ammonium sulfate, but let's write the mass of the fertilizer. So this sample is 1.455 gram, and we know we reacted with sodium hydroxide. You would have written the volume and the concentration, so we know we can use that. Alright, and remember, whatever is used in the reaction, that's the total. So the mole of sodium hydroxide is concentration times volume. Concentration was 0.2 moles per dm cube. The volume was 25 cm cube, so 0.025 dm cube. And so the mole is 0.05 moles. The reaction now is between ammonium sulfate plus sodium hydroxide. I'm going to get sodium sulfate So that's our equation. Again, write the mole ratio. It's between ammonium sulfate, sodium hydroxide. So it is 1 to 2. Once you have the mole ratio, you move to the titration. For the titration, we have the HCl. We have the HCl, and the concentration of which was 0.1. So let's find the mole of HCl. So that is 0.1 moles per dm cube times 0.0287 dm cube. So we get the mole, which is 0.0287 moles. So we get the mole of HCl that reacted. Once you get that, by now, you are supposed to be used to this. Sodium hydroxide was in excess, so it's sodium hydroxide plus HCl, get sodium chloride and water. And we know sodium hydroxide, HCl, it's a 1-to-1 mole ratio. So the unreacted NaOH is equal to 0.00287 moles. So the reacted NaOH is equal to 0.05 take away 0.00287. And we end up with 0.047 moles. Alright, so that's the amount of sodium hydroxide that react with your ammonium sulfate. So now we're interested in finding the moles of ammonium sulfate. 2 moles of sodium hydroxide, 1 mole of ammonium sulfate, so mole of this is equal to 1/2 times 0.047, and we end up with, right, this was not finished. Right, so 0.0 divided by 2 get 0.0235 moles. So after I get the moles, we know that mass is mole times molar mass. So the mole is 0.0235 mole times the molar mass for ammonium sulfate. Let's do that quickly. So it's 4 oxide. Let's start here. 2 nitrogen, that's 28, plus 8 hydrogen, plus 1 sulfur, plus 4 oxygen, that's 64. So 28 plus 8. 1 sulfur is 32. And the 4 oxygen, that's 64. So 132. 132 gram per mole. So 132 times 0.0235, we get 3.1 gram. Now let's check back something, don't match up. The mass I get cannot be more than the sample. Let me check back. Okay, so the error was from here. So you're supposed to get 0.005. So it's 0.005 mole and not 0.05. So and this would become and we get 1.065 times 10 to the minus 3 moles. Alright, so again, mass is mole times molar mass, so let's just put back that there. Alright, so now we're finding the mass. So it's 1.065 times 10 to the minus 3 times the molar mass, which was 132, and we get 0.14 okay, so 0.6 grams. Alright, so that's the mass of the, what are we finding, of the ammonium sulfate. So remember, percentage is the mass of the compound. So I'm going over here and calculate the percentage. So percentage is the mass of the compound, in this case 0.1406 divided by 1.455 times 100. With 9.66%. Alright, so that's that. So I think you should be pretty okay now. So just with the 3 questions, it's the same technique we use to calculate each of them, and you can apply it to any back-titration question I get. Separate the reaction and the titration. Whatever you get the concentration and volume for in the reaction portion, calculate the moles for it, that is the total. Write the equation for your reaction and mole ratio. Stop there, you move over to the titration. Again, you're going to calculate the moles, write the balance equation, use the mole ratio to get the mole of the unreacted substance. So whatever was the total over here, it will be the unreacted over here, so it's sodium hydroxide. We get the unreacted mole of that, you subtract total minus excess, gives you the moles that actually reacted. So that is what you come now and find. Use back the mole ratio, get the mole of the ammonium sulfate, mole times RMM, that gives you the mass. And of course, percentage is mass over the mass of the sample. Mass of compound over mass of sample times 100. Alright, so that's it for this video. If you have any question, leave it in the comment section.